Namaste and welcome to episode 9 of Cyber Awareness series. Today we are going on a deep dive into a piece of cloud security research that is as fascinating as it is critical. The title on your screen says it all. Expanding privilege in the cloud, exploring security boundaries in Amazon ECS. We are about to uncover where the real line of defense is drawn in a popular AWS service. Our guide for this journey is Naor Haziz, a software developer and security researcher from Israel working with the team at Suite Security. It is his discovery and presentation at Black Hat that we are breaking down today. Let's map our journey. We have 6 clear steps. First, our agenda, then the technical background we must understand, the story time of how this was found, a deep dive into an attack itself called Escape. We will look at its impact and see a demo. Finally, and most importantly, we will cover our mitigations, how you can protect your own systems. But why should you care? Look at these statistics. 1/3 of the developer using container orchestration rely on Amazon ECS. That's a massive chunk of cloud. If there's a fundamental flaw here, it affects a huge number of organizations worldwide. Let's build our foundation. First step, technical background. In AWS, everything starts with IAM's identity and access management. You have a role, which is an identity for a service, and you have a policy, which is a document that says what the role can and cannot do. This is the core of AWS security. For example, a policy like Amazon S3 full access give a role total control over S3 storage. Amazon EC2 full access let it control virtual server. These are powerful key to the kingdom. How does a program use a role? It assumes it. When it does, AWS give it 3 things: an access key ID, a secret access key, and a temporary session token. Think of them as a username, password, and one-time code. Together, they are temporary credentials that grant power until they expire. What is Amazon ECS? Simply put, it's AWS' own platform for running and managing Docker containers. You can think of it as AWS version of Kubernetes. It's a major player in the container world. You run ECS on a cluster, which is a logical group of EC2 instances, your virtual server. This server forms a pool of computing power for your containers. Everyone on these EC2 instances has an IAM's role attached to it. This is called the instance role. For an instance running ECS, this role typically has a policy with a name like Amazon EC2 Container Server for EC2 role. This allows the instance to talk to the ECS server on your behalf. So we have our EC2 instance. On ECS, you define a service. A service is a long-running application like a website backend. That service runs and manages one or more tasks. For example, a web server service might run on a single task instance. When traffic increases, the service can scale up by launching multiple identical tasks. A task is a logical grouping of containers that run together. One task can have multiple containers inside it, like a main app and a helper container for logging. Now, crucial for security, each task can be assigned to IAM's role. The task execution is used by ECS system itself to put image or fetch secrets. The task role is given to your application code inside the container to access AWS services. So, a task is running. It has a container inside, and the container uses the task role to call AWS APIs. Here's the critical setup. On a single EC2 instance, you have multiple tasks, each with a different IAM's role. Task role 1 might only read from S3. Task role 3 might have admin powers. The promise is that these roles are isolated. Task 1 should never access role 3's privileges. There are 2 main ways to run tasks in ECS. Fargates, which is serverless, and EC2 launch type, where you manage the servers. Today's entire story is about EC2 launch type. On that EC2 instance, a special software called ECS agent is running. This agent is the middleman. It communicates with AWS and manages tasks. To do its job, it uses IAM's role attached to EC2 instances, the instance role. So again, EC2 instances, ECS agent, and the instance role are all linked. The ECS agent is the one talking directly to AWS cloud. When an instance first joins a cluster, the agent registers it. AWS then knows it is a container instance and give it a unique ID. You can see that status here is active. With that background, let's switch gear to human story. Part 2, story time. Naor Haziz started with a simple practical question. Can you monitor ECS tasks? He wanted to see what tasks were doing. He looked at ECS agent on EC2 instance, which manages the Docker containers. But understanding the agent's communications was tricky. It wasn't a straightforward network traffic. So, he uses another method. Every ECS container has a special endpoint injected by AWS, the tags metadata endpoint. The official docs say it provides various tags metadata and Docker stat. He queried from inside our container. The output shows detail about his tags like service name. He saw a service named High Prep Service. He wanted to learn more about it, but that required an API permission his low privilege tags didn't have. He hit a wall. This led him to intercept the traffic. He set up a proxy, and here he saw something astonishing. He caught the ECS agent talking to AWS over a WebSocket. This message contained IAM role credential message, and inside in a plain text with the full IAM credentials for a different tags, the access key, secret key, and token. He noticed a key detail in a WebSocket connection URL. The parameter send credential equals true. Here's a close look at that credential message. It has everything: the role ARN, the access key ID and the secret access key, the session token, and an expiration time. This was a complete identity of another task being sent over the network. This sparkled the critical question. If the agent can get everyone's credential, can I, a simple task, pretend to be the agent and get them too? This idea was exciting for a researcher, but also daunting. It means going against the normal flow. And this is how attack got its name. Part 3, Escape. First, he did what any good researcher would do. He looked at the source code. The Amazon ECS agent is open source on GitHub. He studied how it works. This code showed him the agent uses EC2 instance role to call an API name ECS:register container instance. This API registered the instance, making it so as an active container instance in the cluster. AWS documentation for this API has a very interesting note. This action is only used by Amazon ECS agent, and this is not intended for use outside of the agent. After registering, the agent gets a special WebSocket URL to talk to AWS. It gets this by calling another API, ECS:discover poll endpoint. So the agent has its communication URL. To connect, it sends its agent version, cluster name, container instance ID, and that crucial parameter, send credential equals true. All this communication is signed and authenticated using EC2 instance roles credentials. This agent sends a request signed with the instance roles key to the WebSocket endpoint. If the signature is valid, AWS accepts the connection. The agent is now pulling for messages. Once connected, because it asks with send credential equals true, AWS starts streaming IAM's credential for all the tasks on that instance to the agent. This private channel is called Agent Communication Service or ACS. It sends three things: task metadata, command for the agent, and IAM's credentials. So, the agent's authentication flow is 1. Use the instance role to get a WebSocket URL. 2. Use the same role to sign into the WebSocket. 3. Ask for the credential. 4. Receive them all. The billion-dollar question. Can a task perform this same flow and impersonate the agent? The first hurdle is permission. A task cannot legally call ECS:discover poll endpoint unless it has instant roles credentials. The attacker, which we call the skip task, starts by trying to find that WebSocket URL. But just knowing the URL pattern isn't enough. You need valid credential to sign the connection request, a dead end. Then, the attacker remembers the fundamental features of EC2, the Instant Metadata Service or IMDS. Every EC2 instance has a magical IP address 169.254 192.169.254. Any process on the instance can ask this address, who am I, and it will reply with the instance's metadata, including the temporary credential for the instance role. This is the first major breakthrough. The ECScape task queries the IMDS and steal the EC2 instance role's credential. Now it has the power of instance itself. Next, it needs the container instant ARN, a unique ID for this EC2 within ECS. The task looks at its own metadata endpoint. The output is long and detailed, but this specific ID is not there. This was a setback. The attacker thinks maybe there's another API, but no, it lacks permissions. Maybe it's in the host file system. The task can mount the host root drive and search. Still no luck, another dead end. But then the attacker discovers a backdoor. The ECS agent itself runs a small local API for debugging. It's on port 51678. Attacks can simply curl http://localhost:51678/v1 and bingo. The response includes the exact container instance ARN and the agent version needed. And this is a feature, not a bug, meant for diagnostics. So now the ECScape task has stolen the instant role credential from IMDS and has extracted the container instant ID from the agent's own API. It has all the pieces the real ECS agent has: credentials, ID, versions. Now it attempts the impersonation. It creates a WebSocket connection request just like the real agent would. It signed this request with a stolen instant role credential. It sends the stolen container instant ID. It includes send credential equals true. AWS received this request. It checked the signature. The signature is perfect because it makes with the real instant role key. It checks the container ID. It matches. AWS is completely full. It accepts the connection. Now the attacker is in. AWS starts sending credentials message. Here is a cloud trial log entry after the attack. See the user identity field. It shows the API call was made by ECSstock.amazonaws.com. It looked like it came from a lazy-made ECS task, not from an attacker. This makes a detection incredibly hard. Let's recap the final complete ECScape attack flow. 1. Steal instant role creates from IMDS. 2. Use them to get the WebSocket URL. 3. Steal the container instant ID from the local agent API. 4. Connection to AWS impersonating the agent. 5. Harvest all IAM's credential from AWS control plan. And just like that, success. A low privilege task has hijacked the IAM's role of every other task on the machine. Now, here is the shocking part. This directly contradicts an AWS documentation page. It states a container can only retrieve credential for the IAM's role that is defined in the task definition to which it belongs. A container never has access to credentials that are intended for another container. Another page says these permissions aren't accessible by the container in the task. Our attack just proved both of these statements fail in the ECS launch type. Let's be clear about the impact. 1. Cross-task IAM's role hijacking, still powerful rules. 2. Abuse of the task execution role to pull private images or secrets. 3. Full access to ECS internals via through local API. And 4. No misconfiguration is needed. This works on a default standard setup because IMDS and the instant role are enabled by default. The researcher published a proof of concept on GitHub to demonstrate this. If you want to see the code, scan this QR ID. A reminder, only use this for legal educational research in your own environments. Now, the most important part. How do we fix this? Part 6, mitigations. Mitigation number 1, the most critical. Disable IMDS access for your tasks. AWS provides clear guidance. For most network modes, you can use an IP table rule to block access to IMDS IP from container. For the AWS VPC mode, you can set an environment variable ECS underscore AWS VPC underscore block underscore IMDS equals true in the ECS config. If the tags can't reach IMDS, the attack failed at step 1. Mitigation 2. Apply the principle of least privilege to your tax rule. Give each tax only the permission it absolutely needed. This limits the damage if a role is stolen. Mitigation 3. Also minimize permission for the tax execution rule. It only needs to pull image and write logs, not access your data. Mitigation 4. Architecture. Never run high privilege and low privilege or on-trust workload on the same EC2 instance. Separate them physically. Mitigation 5. If you have a multi-tenant system where different customers' stacks run, you must isolate them completely using separate instance or clusters. Best practice summary: separate workload, isolate tenant, minimize all permissions. Finally, let's see the summary and how AWS responded. AWS Security's initial response was that this was not a security concern for AWS. However, they agreed to update documentation and consider future changes. And they did update it. The old line about a container never accessing another credential was changed. The new documentation now say tags credential are isolated at the EC2 instance level. Tags running on the same EC2 instance may potentially access credential belonging to other tags. For strong isolation, consider using Fargate. This is a huge, honest clarification thanks to the research. AWS offered a formal statement of appreciation for the researcher to include in his talk, acknowledging the finding. Later, they published this acknowledgement, thanking Switch Security and Naor Haziz for highlighting the need for clarity, which led to documentation change. So the final summary is threefold. 1. On EC2, tags and ECS agents share one trust boundary, the instance itself. 2. Attacks can impersonate ECS agent by exploiting default features. 3. Because of this, tax level hardening is not optional, it's essential. Thank you for watching. A massive thanks to Naor Haziz and Switch Security for his brilliant research. You can find Naor Haziz at his email and on LinkedIn. Check the description for links. Stay curious and stay secure. Goodbye.